Awesome. We're just all connecting here. We'll give it a few seconds. Awesome. Thanks so much, everyone, for joining us today. Welcome to our virtual March open house here at Carleton University. I'm so excited that you've made the space to hear some more about what's happening in computer science and what's happening at Carleton. My name is Caitlin Anderson. I'm the National Recruitment Officer here at Carleton. And we are so excited to have you and to answer questions and to make sure that you feel even more excited about your next steps here at Carleton. Before we get started today, I'd just like to cover off a few things. If you have questions, feel free to navigate over to the Q&A tab and pop your questions in there. We'll be answering some of those during the session here today and some of them in the booth after the presentation is completed. I ask you to use the Q&A tab so that we can keep track of what's happening, and you can upvote questions that are there if you really want to hear more, and make some comments there. Before I hand things over to our folks here in computer science, before we start any presentation at Carleton, I always like to make some space to acknowledge the location of our campus. So Carleton is located in Ottawa, Ontario, but we're really also located on the traditional and unceded territory of the Algonquin Nation. Something that's important to us as an institution, as faculty, staff, and students, to recognize the privilege that we have to learn together and grow together on the beautiful land that is Carleton's campus. And there's lots of stuff happening at Carleton when it comes to Indigenous education, recognizing our history, and bringing that into the classroom. And I encourage you to take a look and get more information either by joining us at our Indigenous Access booth here today, or checking out carleton.ca/Indigenous to hear all that's happening at Carleton. But that's enough for me. I'm not the person that you came here to hear from. I'm going to hand things over to Dr. Michel Barbeau, our director of the School of Computer Science, to share some more information on what's happening in the program. So over to you, Michel.
Okay, good morning, everyone. My name is Michel Barbeau. I am the director for the School of Computer Science, and I'm accompanied today by Christine Laurando. She's the associate director in the School of Computer Science, and we are both professors, and we are teaching courses in the program, and we are both doing research also in computer science. And we are here today to talk about the Bachelor in Computer Science. It's the main program that is offered by our unit, the School of Computer Science, and we are part of the Faculty of Science. How's everybody today? So you can type chat, you can say hi in the chat. Okay, very good. And so I will go through the slides, explain a little bit what the program is, and you can post questions in the chat. Christine will help me to answer some of them.
Actually, Michel, it'll be in the Q&A tab, not the chat.
Yeah, the Q&A tab.
Yeah.
Sorry. And at the end, we will have a question period. And also, we have a booth. At the end, we will switch to the booth, and we will be available until 1 p.m. if you want to talk with us and get more details. Okay, so let's go. So first of all, I would like to explain a bit more what is computer science, because one of the things we have observed over the years, so people jump into computer science without knowing exactly what it is. And a common misconception is that computer science equals programming. Okay, programming or coding. It is true that in computer science is a lot about programming. Okay, so our main focus, we learn how to construct software for computers. So you have to learn how to program. But computer science is much more than that. And if we simplify it, it's a very broad topic, in fact. But if we try to simplify a little bit, and this simplification reflects at the same time what we are doing in the program, so we can say that computer science has a theoretical or foundation aspects, or it can be called algorithms also. And the computer science has an engineering aspect. Okay, so engineering is a big word, but at the end it means applied science. Okay, so computer science has a science aspect, foundations of computing, algorithms, and it has an applied science aspect, so software engineering. All students, who take the program, they go through the foundations. There are mathematical foundations, and there are computational foundations, and they learn how to build complex software. Okay, and roughly the program is structured like that. And often there's a question. So we get many questions, but a very common questions is, okay, so in computer science you do software engineering, but what's the difference between software engineering in computer science and software engineering in engineering? The answer is simple. Two things. In computer science, the focus is on software. We don't do any hardware. Okay, so engineering, they tend to do a mix of software and hardware. And so for us, the focus is really on the foundations of computing. So we go much deeper into software. Like if you look at the number of software courses we have in our program, it's much more than in an engineering program. So if software is your passion, computer science is for you. I would say if you're more inclined, so in computer science, so we deal a lot with software. Software means logical, means abstraction. So abstract thinking is very important. We work with computer, but we develop software, and software are virtual artifacts. Okay, we don't build bridges, we don't build roads. Okay, an engineer will design a bridge and eventually can drive their car on the bridge. So you will not drive your car on your software. So computer science is a little bit more abstract. It requires, in terms of skills, you need to develop abstract thinking skills. And so that's maybe the main challenge at the beginning, to develop this abstract thinking if you don't really have it. Okay, a bit more example about, a bit more details about what computer science is. Okay, I'm going to give you two examples. One is artificial intelligence. We all hear about artificial intelligence, robotics, deep learning, okay, all the progress of and the room that artificial is taking right now in all areas: business, manufacturing, finance. Any area right now builds on artificial intelligence. So what is artificial intelligence? Artificial intelligence, in two or three words, what we're trying to do, we're trying to mimic humans' brain. Okay, all humans human reasoning. And who develops the foundation of artificial intelligence? Computer scientists. Okay, AI is at the core of computer science. All the foundations of computer science, of AI, are developed by computer scientists. Okay, and other areas, they use computer science. They are users of AI techniques developed by computer scientists. Another example is computer and internet security, or cyber security. What's that? So when you do a transaction on the internet, banking, or you buy something in a store online, you feel secure, okay, or relatively secure. Why? Okay, because behind there is computer and internet security, protocols, architecture, cryptographic algorithms, okay? And who designs these things? Computer scientists, okay? Computer science is behind the creation, evolution, maintenance, and design of the future computer and internet security. So these are two examples. And just recently, just to give you an example of what a computer scientist did in Canada. So Canada is very strong in computer science. We have in Canada some of the smartest brains in computer science. We have a worldwide reputation in computer science. Theory, AI, computer and internet security. And just to give you an example, two Canadians were awarded the Turing Award not too long ago because of their work in AI. And these guys are computer scientists. And the Turing Award is the equivalent of the Nobel Prize, but for computer science. Okay, another example, software engineering. Okay, a little bit more about software engineering. So when in our program we have specializations, we call them streams. Okay, one of them is AI, one of them is computer and internet security. I talk about these topics, and one of them is software engineering. Okay, so so I would say these three streams are the most popular right now. And now a little bit more about software engineering. So what is software engineering? Why do we need software engineering? There's a little picture on the right. The picture shows a lady named Margaret Miller, and she worked on the development of software for the Apollo program. And she's standing next to a listing of software. We don't do that a lot anymore, but if you go back 10 or 20 years ago, we used to print our software, our code, okay, to review them and to store them, to archive the code, and to work on it. And this picture gives you an idea of what it involved in terms of code for the Apollo program. Okay, so at the beginning of in the early days of computing, we quickly realized that programming skills are not enough for software creation. We need more than that. Okay, so software creation is a complex process. So we need to approach the problem with methodologies. So what is software engineering? So software engineering is about that. It's about skills, methodologies for addressing properly difficult software problems. Okay, I'll give you an example. Capturing the needs of the actual users of software. All the users will interact with the software. How we are going to structure the software, the architecture. How are we going to break a complex problem or structure a complex problems into smaller units that are easier to address. What can we reuse from the past? Okay, software right now is a lot about reuse. So we rarely start from scratch. We reuse frameworks and libraries developed by people who work on the same problems before us. At the end, how do we ensure the quality of what we did? Quality assurance. The design of tests, the design of validation processes, document. Okay, how we explain what we did so that the people who will come after us will be able to understand what we did. Okay, software engineering is about that, and that's one of our specialization. Okay, now a little bit about the structure of the program. So we have two bachelor in computer science. We have two main programs. We have the major program and we have the honors program. So first of all, both programs have almost the same core. Okay, so you will all learn about algorithms, software engineering, programming languages, and other topics that are in the core of computer science, such as operating system, database, network and web applications, and all the math foundations of computer science. A good computer scientist needs to have knowledge in all these areas, okay? Because a modern software will involve typically most of these aspects. And so all the students are going through that core. They learn that core, and so it's a 4-year program, 2 terms a year. Each term you take 4 or 5 courses. But if you want to do it over 4 years, you have to take 5 courses. Each term, there's a number of core courses that you have to take, together with electives and some math courses. Now, something very important in computer science, you learn there is material through which you have to go through. Okay, there are things to read, there are concepts to absorb, to study, but you learn also a lot by doing. Okay, and where do we do that? So each course, for each course in computer science, there are formal lectures, typically 3 hours a week. Okay, and also there are tutorials. Most of the first year and second year courses have tutorials. So it's about an hour a week, an hour and a half per week, where you review and you practice in more detail the concept you have done in courses. And in addition to that, you have many opportunities to build experiential learning, okay, to do. One of them is the co-op option. So the co-op option is really great. Both Christine and I we did it. And for me, doing co-op, it's during co-op that I really learned, I really discovered what I wanted to do with my life as a computer scientist. Okay, because I saw what was happening actually in the industry, what it involved, what it required, what was the day-to-day work of a computer scientist, and what were the options, and what kind of skills I needed, and what I had to do to actually reach my goal as a computer scientist, as for my career goals for my life as a computer scientist. So I did the co-op option. At Carleton, the co-op option, so it's 5 work terms. If you sign up for this option, you do 2 full years of study terms, 4 study terms, and you start your co-op in your second summer, and you do 2 co-op terms, and basically after that you alternate study, co-op, study, co-op until the end, and you have a total of 6 work terms, 6 study terms to do, and 5 co-op terms. Okay, there are several other co-op options. Is just one example. We have the industrial application internships or dev degree with our industrial partner Shopify. During your program, you have many opportunities to get involved in research if you are interested, to work more closely with one of your professors. There are several programs for that at Carleton. Okay, so we have the major program, we have the honors program. In the honors program, for both you can take the co-op option. In the honors program, one of the major difference, and now I'm digging a bit more into the differences between the major and honors. In the honors program, we have specialty streams. Okay, so specialties, each stream has a profile, and this profile gives you the opportunity to dig deeper into a topic of interest to you. And eventually, when you graduate, you have an edge with respect to other candidates in the topic. Okay, so it's an opportunity to go to develop one of your passion in computer science. Software engineering, computer and internet security. We have also one of the very popular streams is computer and game development. AI and machine learning, I mentioned that. We are starting this new program this fall. We got a lot of applications for this program. Industrial application internship. So once you are admitted in the program, you have the opportunity to apply for this option. And we have a few more. We have seven streams in total. Okay, so I talk a lot about the core, and but there are many other courses. So first, second, and third year, you mainly concentrate on the core. There's a few options also available outside the core, but starting mainly from third year and basically in fourth year, you will have a lot of options for going deeper in specialized topics of computer science. We have a first year course that introduce students to robotics. We have courses in human-computer interaction, computer graphics. If you want to go deeper in that topic, we have courses, parallel programming, multi-core processors, computer vision, AI, of course, machine learning, neural networks, and computer and internet security. Okay, so one question that we often have is what kind of programming languages that we teach. Okay, so first of all, I think one answer to that is we are not teaching a programming language. We are teaching the foundations of programming languages. Okay, and so with a computer science degree, you learn how to program, and you learn the foundations behind all the modern programming languages. Of course, to do that, you have to learn some specific programming languages. In your first year, you will learn Python, you will learn Java. Okay, Python for the for your first course in programming, Java for the concept, for the object-oriented concept. After that, you will learn in second year, you will learn C, C++, JavaScript for web development, and you will learn many more programming languages. But more important than that, you will learn how to learn new programming languages. Because it's very likely that, okay, we are March 2022, you will graduate in 5 years, okay? And where will computer science be in 5 years? I cannot tell exactly, but I can tell you for sure there will be new things. Okay? There will be new programming languages. There will be new operating systems. And with a computer science degree, you will be prepared to adapt and learn these new programming languages, these new programming environments, and these new operating systems, because you will have the science behind that. Okay, this is very important for computer science. This is the main. So in computer science, there is the term science. Science means the core ideas behind computing. Okay, so we teach the core, not only how to program computers, but what is the science behind. So you will be adapt to this field that is all that so far has evolved so much. And the only thing I can tell you is that it will continue to evolve. And I don't know for how many years, but probably for a long time, because computer science is a young science. We are like pioneers. Okay. And we are like pioneers if you compare to other areas like chemistry or physics, who have been established for hundreds of years. Computer science is relatively new. So it's still evolving, and it will evolve again, and you will be prepared for that. One thing I would like to mention is, programming is development of programming skills is, of course, important. When you join the program, we assume that the students have no programming experience. We start from scratch, okay? So, but if you have some experience, that's very good. If you have none, before you join the program, during the summer, we have a course. It's non-credited. There are no exam, no evaluation. It's called Comp Matters. It's about 2 or 3 weeks, and before you join the formal program that starts in September, you can get some. You can develop some basic skills in computing. So develop learn some foundations in Python. Okay, so this will be posted on our website. I highly recommend that if you don't have any programming skills. Okay, there's another point here for the co-op option. There's one of the nice things about being in Ottawa is that you can do your study terms and your work terms in Ottawa, because we have a lot of co-op opportunities available in Ottawa with companies and with governmental offices. And the placement rate for co-op is very high. Okay, so a little bit about just to give you a more clearer idea about what it looks like to be a student at Carleton. Just show you a little bit about the profile of the first year. So this is the program, how the program looks like for computer science courses in the first year. So I mentioned about streams, but all students in first year, they are doing 3 computer science courses. And the first one is Comp 1405. So they learn the foundations of programming, functional programming, the basic statements, loops, how to structure code into function, procedures, a few about the few basic concepts about data types, data structures, a few software engineering concepts, a few computer science concepts, so how to test, how to design, write pseudocode, how to analyze the complexity of a design. So typically students do 1405 in the fall. They will do 1406 in the winter, and 1406 we go deeper into programming and the foundations of computer science. So basically the students they learn the object-oriented concepts: classes, object, inheritance, polymorphism, so ideas like that. And fall or winter, but a lot of students are doing it in the winter, it's the 1405 course. And so the 1405 course, I would say it's a discrete math courses. The 1805 course, sorry, teaches the math aspects that are necessary for a computer scientist. Okay, and if you take the game development stream, we have 1008 that goes deeper into math for game development, and we have 1501 it's our first game course. Okay, and if you happen to be in the internship option, there are 2 internship courses, during one in the first term and one in the winter term. Okay, after first year, you will go deeper into more advanced topics. In the first year, you learn the foundation, some concept about algorithm and software engineering, but we have specialized courses in algorithm, software engineering. You will learn more about programming languages. You will learn more about computing systems, for instance, computer networks, distributed systems, and you will have opportunities to go broader on topics such as computer graphics, artificial intelligence, and security. Okay, so often we are asked, so what is unique about Carleton? So I would say we specialize in certain things. I gave you examples: AI, software engineering, computer and internet security, game development. I think we are very strong with experiential learning, with many opportunities to learn by doing. The industrial application internship option is one of them. Co-op. There are many other opportunities, and one thing that is important to mention: universities, they have a dual. Every university has a dual mission. So we teach and we do research, and research is important. For the simple reason is it's a way to keep us up to date, okay, to follow the evolution of the field. And we have a very strong research program, and we actually Carleton ranks extremely well in research in Canada. We are among the 10 top universities in research. And honestly, that's not easy to achieve. So we have a very good reputation in research. And it's a good sign, and because it means that we follow the evolution, we keep ourselves up to date. We don't know where we're going to be in 5 years in computer science, but one thing I can tell you for sure: Carleton will be there. The School of Computer Science will be there, because we watch and we follow and we try to understand and we try to adapt our program to the evolution and for the benefits of our students. Another strand is, so we have a very good reputation. Graduates for our program, they find job easily because of the reputation of Carleton. And there are many more, and there's many more about the program. We have also very qualified people to teach. I would say Christine is one of them, and I would like to open the floor to questions. And so anything, again, we can take a question right now for about 20 minutes in this environment, and we will be available in the booth for individual question after that from noon to 1 p.m. And if you happen to be in the Ottawa area next week, I will be on campus at noon. If you want to meet me in person, and I will show you the server room and also the some of the labs, some of the space we have for undergraduate students. And you can sign up for this in-person tour that will be March 19 at noon on campus at Carleton University in Ottawa. So your question now.
We've gotten a couple of questions in the Q&A regarding options for skipping courses. As I've answered, most universities don't allow students to skip courses. Our courses are at the university level, which is very different from the kind of experience that people learn on their own. And we're accredited by the province of Ontario to be able to grant these degrees. So we have to make sure that students are at the right level. So that's why we can't just, allow people to skip courses any way they want. Any other questions or any questions that I've answered in the Q&A that people would like more details on? Or I know some of the questions I answered really quickly and I wasn't really able to type fast enough to give a very in-depth answer. But I mean, if there's any question that that you want me to get back to, that we can certainly do that. Just type in the Q&A and we can address those questions again. It was really nice to answer your questions. So there's a question here, is co-op guaranteed if we sign up, or is there an application process to see if we're eligible? So you can be admitted either in co-op or not in co-op. Regardless, co-op doesn't really start until after second year. So at the beginning of second year, you would have to still qualify for co-op. So your grade point average, like your grades, would have to be above a certain average. And then there's an introduction course, Co-op 1000, I think, that you have to take. And there's a couple of courses in second year that you need to complete in order to go out on a work term. So have students found co-op opportunities in U.S. companies? I've had a lot of students who've found permanent jobs in the U.S. That happens a lot. For co-op, a lot less so, because we have a co-op department that puts together these job postings, and most of them are in Ottawa. There's a few outside of Ottawa, but most of the time, if you want to do a co-op in the US, it would be on you to find that opportunity and then get it approved by the co-op department. So that's a possibility. So Michelle, could you put the co-op slide? Someone wants to see that again. So any tools that I'd recommend for the course, like IDEs, it really depends on the prof. For example, in my courses, we don't use IDEs because I teach low-level systems programming, and it's important to learn to code from the command line. So it really depends on the course and on the instructor. So on your UAC page, it says computer science co-op optional. Does that mean you're accepted into co-op? I'm not sure. Co-op optional.
Yeah, actually, the co-op option, you have to complete the first 2 years, 4 terms with all the courses, and there's a minimum grade. I think it's 80%, and you can join co-op at the beginning, and you can also join co-op anytime if you meet the requirements. So the fact that you are accepted or not right at the beginning, it's not that important, because you can join a co-op anytime if you meet the requirements. You have always the option of taking co-op.
Michelle, did you, if some people want to see the slides, the slide that has the alternating terms for co-op. I don't know if you still have, it's in a different PDF file. I have it. If
Okay,
you do.
I don't have it, so yeah, you can share your screen.
Okay. So this is from an old presentation. So let me just go to, oh my goodness. I'll have to find where that is now. I had it right here. So those of you who wanted to see, so in first year, in the F is fall, W is winter, S is for summer. And down here in the second row, that's S is for study term and W is for work term. So in first and second year, it's all study terms, except the summer after second year, right? You do 8 months of co-op. So the summer after second year and the fall, right? And then in the winter of third year, you do a summer term, a study term, then you go back on co-op for the summer. Then in fourth year, you finish off your third year courses in the fall, then go back to a final 8 months of co-op. So that's how that would work. Okay. Low-level languages, I teach C. So you learn C in second year, and then C++, which is built on top of that. Blockchain technology, what specialization is recommended if we want to go this way? Michelle, do you know?
Yeah, it's definitely computer and internet security. And so you will cover the stream covers the foundations that are required in cryptography and the architecture, the protocol concepts and network architecture concept. I see there's a question about registration to the tour. I think if you Google Carleton March open house, it will take you there. I can try to find the link, and I will post the link in the chat.
Okay. We're getting a little prompt from our host here, telling us that we should, just take just a few last questions. So, any last questions? Otherwise, we'll be in the booth, so you guys can join us there as well.
Yeah, I just posted the link to the web page. And so if you scroll down to March 19, there's a link for registration to the tour. I can show that.
Okay, so there's a question about what if a student could not find a co-op job in the fall of second year? Well, fall of second year is still a study term, fall and winter. The first work term is the summer after second year. If you can't find a job then you can always do that, do that later on in the program. As long as you do 16 months, I think it's 16 months of co-op before graduation.
And I think it's important to mention is that you're not left alone to find your co-op job. We have a co-op office.
Yes.
That post job offers, co-op opportunities, student apply, and there's an interview process and a selection process.
Yep. Mobile development, there's a question about that. Do we still have those courses, Michelle?
No, the program stops. We don't offer this program anymore.
But the courses themselves, we've gotten rid of those as well?
We don't offer all courses. We don't offer the first year course anymore. So the program is progressively shutting down. So we accepted the last cohort last year, and they
Okay.
are in their second year. So we just offer second, third, and fourth year courses for this stream. We don't offer the first year courses anymore.
Okay. There's another question from someone taking a second degree. And if they get all of their math course credits transferred, we need to revise it for other courses. I'm not sure what that means. You'll get credit for the math courses that have equivalencies at Carleton, but probably not for the computer science courses unless you've taken an equivalent somewhere else. There's the question, is it possible to not follow the terms on the slide? To do that, you would need approval from the co-op department. You'd have to have a really good reason to justify, doing something differently. Is this how co-ops are, the co-ops that you're looking at here, the schedule, that's for computer science only. Other departments, other programs, they have their own way of doing things. So you'd have to see how they organize their co-op. So tuition fees during the co-op terms, I'm not an expert on that. That would be more registration people, but I believe that it's not full tuition. It's not, but there's some kind of fee for when you're on a study term.
Mhm.
Okay.
There is probably some information on the website of Carleton, but there is a booth for the registrar's
Oh, the
office,
registrar's
and
office.
you will get the details like that.
Someone is interested in data science. So what stream would we recommend? Would that be the AI stream?
AI or algorithms.
Okay, sounds good. And last question, is ICS4U required? I don't really know what that is, to be honest. ICS4U. Does anybody know what that is?
Let's Google it.
Computer science in high school? No. The what you need from high school? Yeah. So what you need from high school are the math courses and of course English. Like you need to graduate for a grade 12 English, right? So I believe that's on our admissions website as well. But you do not need the high school computer science course. It would help, but it's not required.
Yeah. If you had a chance to do it, that's great, but we don't require it.
Response time 4 to 6 weeks still apply if we're coming from Algonquin College computer programming pathway. That would be a question from admissions. We don't deal with admissions. We're the actual computer science professors. So if you have questions about computer science, that's what we're here for. But admission things are really out of our wheelhouse. Okay, so Caitlin, are we wrapping this up?
Awesome. Yeah, thanks everyone so much. Lots of great questions, and know that you can continue the conversation. Just head over once you leave here to the booths tab. If you have questions about admissions, co-op, things like that, you can head to the services tab. Or if you have questions about computer science, you want to continue this conversation, head to the academics tab and click on computer science. But thank you so much for joining us here this morning. I hope you have a wonderful rest of your virtual March open house. And we look forward to seeing you at CU very soon. Thanks so much, everyone.
Bye, everyone.
Bye. Thank you for coming.